We are pleased to have you all here today with us. I'm Meredith Brasselman with ICF Next, and our team will be guiding you through the workshop today and the workshops throughout the month. First, though, we have a few housekeeping items. If you would like to use closed captioning, please refer to the link that is in the chat box. Please also note that this WebEx call is being recorded and may be posted to the Department of Energy's website or used internally. If you do not wish to have your voice recorded today, please do not speak during the call. If you do not wish to have your image recorded, please turn off your camera or participate by phone. If you speak during the call or use a video connection, you are presumed consent to recording and use of your voice or image. If you have any technical issues today, please type them in the chat box and send to the host. We will be muting lines to minimize background. So now about today's workshop. Pursuant to the Department of Energy Research and Innovation Act of 2018, the Department of Energy established the Research Technology Investment Committee, or RTIC, to identify potential cross-cutting opportunities in basic and applied science and technology. The Energy Storage Grand Challenge is managed by this committee. Today, you'll hear from both co-chairs of the RTIC Energy Storage Subcommittee, Alex Fitzsimmons, Deputy Assistant Secretary in the Office of Energy Efficiency and Renewable Energy, and Michael Pesson, Deputy Assistant Secretary in the Office of Electricity. You will also hear from departmental leadership and staff leads and have a chance to ask questions. To get us started today, please welcome Alex Fitzsimmons, Deputy Assistant Secretary for the Office of Energy Efficiency and Renewable Energy. Alex?
All right, thank you very much, Meredith, and thank you all for joining us today. Good morning to all of you. We really appreciate all of you being here. I just want to give a special thanks to ICF and the team that's been so flexible in moving to a virtual format, and I want to give a big thanks to all of you who are joining us here today for this morning and this afternoon. It looks like right now we're over 434 participants and counting, and it's just a great turnout, a great show of force, and that reflects the interest and the importance of the challenge of energy storage. And so thank you all for being flexible, and continuing to engage with us and work with us during what we know are challenging times for you all. So I'm going to keep my remarks relatively brief. As Meredith mentioned, the Energy Storage Grand Challenge was established as a result of the culmination of months of work from virtually every program office across the DOE complex. And the Energy Storage Grand Challenge was announced by Secretary Bruyette in January as a comprehensive strategy to position the United States to be the global leader in the energy storage technologies of the future, including the technology development, but also the associated scale-up and commercialization challenges. Because one of the things that we know, and one of the things we discovered going through the RTIC process, the Research and Technology Investment Committee process, is, we were asked a relatively straightforward question by the Secretary, which was, does DOE have a comprehensive strategy to position the U.S. for global leadership? And if not, what does DOE need to do to have that strategy so that the U.S. can create and sustain its leadership in the energy storage technologies of the future? And so the short answer to that question was no. Although DOE invests around $400 million per year in various energy storage technologies, the department has never had an overarching strategy on storage for what we know is a critical suite of technologies and tools that will enable us to have a more reliable, resilient, and flexible energy system, an energy system that we know is changing dramatically and will continue to change. So that's why energy storage is such a priority for the Secretary and for DOE, and it's the reason why the Secretary announced the Energy Storage Grand Challenge back in January. But one of the things we realized as we were addressing the Secretary's question is that DOE is adept at research and development. We have a long history of significant advances in R&D, but we're not always so good at what comes next. And that R&D is necessary but not sufficient for the United States to be the world leader in the energy storage technologies of the future. And so the strategy that we rolled out, that we're looking forward to getting feedback from all of you today as we develop our comprehensive roadmap, includes research and development as a foundation, but builds on that foundation to include associated scale-up challenges. It's why we rolled out 5 tracks with track leads, and you'll hear from each of them today. That includes technology development, it includes technology transition, it includes policy and valuation, manufacturing and supply chain issues, and workforce development. All 5 of these are, we believe, to be critical factors if the United States is going to lead both on the technology, but then on the commercialization. Because we've seen what can happen when the United States invests resources in developing R&D, but doesn't invest resources in commercializing the technology and making sure that it can be manufactured and deployed here in the United States. So with that, it's why I'm so glad you all are here joining us today. This is the first in a series of webinars that we're going to have to collect critical feedback from all of you as we work to lay out a 10-year roadmap with performance targets that will address all of the issues I just mentioned. And so with that, we're pleased to have 3 wonderful keynote speakers today. Kicking us off will be Undersecretary of Energy Mark Menzies. Then we'll hear from Assistant Secretary Daniel Simmons of EERE, and finally, Assistant Secretary Bruce Walker from the Office of Electricity. And with that, we'll now hear a message from Undersecretary Mark Menzies.
It's great to join you for today's virtual stakeholder energy storage workshop. By any measure, the Trump administration and the Department of Energy see energy storage as a vital part of America's future as a world-leading producer of secure and reliable energy. Indeed, since 2017, the department has invested more than $1.2 billion in energy storage research and development. That's $400 million per year. In fact, one of the principal reasons Secretary Bruyette established the Research and Technology Investment Committee, or RTIC, was to advance a comprehensive strategy in a number of our priority areas, particularly energy storage. Now, to build on the work of that committee, the department established the Energy Storage Grand Challenge. The goal of this challenge is to create and sustain U.S. global leadership in the research, development, and commercialization of energy storage technologies to enable the integration of all forms of energy. Our approach to energy storage incorporates 5 important tracks. The technology development track is focused on R&D with clear performance goals. The manufacturing and supply chains track is focused on technologies and strategies to support and strengthen U.S. leadership in these areas. The technology transition track is working to ensure that our R&D reaches domestic markets through field validation, public-private partnerships, bankable business model development, and disseminating high-quality market data. The policy and valuation track is providing data, tools, and analysis to appropriately value energy storage. And the workforce development track is advancing DOE's programs to train and educate the workforce on energy storage systems. Across DOE, we have a number of key energy storage initiatives underway. At EERE, we support energy storage R&D both for grid and mobility applications. This includes leading the department's applied R&D on advanced batteries, storage hydropower, and hydrogen fuel cells, as well as increased power system flexibility from thermal storage, renewable energy generation, and flexible loads. In the Office of Electricity, we are proceeding with the new grid storage launchpad, which will accelerate materials development, testing, and independent evaluation of battery materials and systems for grid applications, so we can advance the long-duration energy storage needed to ensure grid resilience. In the Office of Fossil Energy, we are advancing a range of energy storage technologies and integrating them with fossil-based assets to improve asset flexibility, grid reliability, and environmental performance. Through our Coal First initiative, FE is investing in 7 studies of energy storage integrated with coal-based power generating units. Several of these include a thermal energy storage component. In the Office of Nuclear Energy, we support integrated energy systems research and development, which couples electrical, thermal, and chemical storage systems with nuclear power to produce clean, affordable, and reliable energy. Through these and other initiatives, we believe that energy storage has a phenomenal future. But before I conclude, I want to highlight 2 related challenges we face on the road to that brighter tomorrow: supply chain constraints and end-of-life impacts. The fact is that many of today's storage technologies contain substantial amounts of critical materials that come from foreign sources. Moreover, the valuable materials contained in these technologies often go to waste because they are not recycled. For example, lithium-ion batteries are currently recycled at a rate of less than 5%. So simply stated, we must consider the implications of our use of critical materials as well as the impact of these advanced technologies at the end-of-life phase. We must invest in strategies at every level of the supply chain to reclaim, recycle, and reuse materials into next-generation energy storage. Let me conclude by thanking you again for this opportunity to summarize our important work to help secure our energy future. We look forward to your feedback from the ESGC through the upcoming series of workshops and through a formal request for information. I hope today's workshop you find will be very productive for all of us, and thank you for allowing me to have an opportunity to address you today. Thank you.
Good morning, everyone. Thanks for joining us. My name is Daniel Simmons. I lead the Office of Energy Efficiency and Renewable Energy at the Department of Energy. Thank you very much for joining us here today. This is the world that we're in, so thank you for overcoming all the challenges that we have to be here today. This webinar is one example of the Department of Energy working to carry out our work under these adverse circumstances. So overall, DOE spends has spent since 2017 $1.2 billion on energy storage research, about $400 million a year. And until this year, we did not have an overarching strategy for energy storage. And that is why Secretary Bruyette in January launched the Energy Storage Grand Challenge. Now, from my perspective as the person who heads the Office of Energy Efficiency and Renewable Energy, this is very important. one of the reasons that it's very important is that some of the offices in my portfolio have renewable energy, such as wind, such as solar. Some of the ways that we can unlock the real value of those technologies is through energy storage. That is obvious. We also have our vehicle technology program. Obviously, energy storage is huge to vehicles of the future in terms of hybridization and full electrification. And our hydrogen fuel cell technology office. Hydrogen is a very exciting technology for the future, but we have a lot of work to overcome the challenges of today, as well as with buildings. Buildings are a key way that we can think about incorporating energy storage into the grid, as well as increasing flexibility of the grid overall. So and let me not forget, in fact, it's almost always forgotten, and I almost did it right here. The largest source of energy storage on the grid today is from pumped storage. And I mean, this is the largest source of energy storage. Let's not forget the energy storage that got us to where we are today. So I have this very broad portfolio in the EERE. Energy storage is critical. And one of the things that we like to stress is to think broadly about energy storage. Think broadly, but then work on a overall cohesive strategy on energy storage. So we've seen some incredible cost declines over the past 10 years, especially in relation to with electric vehicles and batteries for electric vehicles. The costs have plummeted, and that is great. We are very excited about that, and we hope to see those kind of cost declines in other types of energy storage as well, because energy storage is critical not only for the electric grid, but also for maybe individual buildings, but also for transportation. So we're looking at the entire picture of energy storage. One of the things that matters is that the United States has been really some of the leaders of energy storage technology in terms of coming up with the idea for the technology. The most recent the most recent Nobel Prize for Chemistry, 2 of the 3 people won for their work were for work done in the United States for their work on lithium-ion batteries. However, the United States has not been a leader in the manufacturing of those technologies. So as we think to the future with new energy storage technologies, looking at how we can not only come up with those ideas for the technology, but then also how to have manufacturing for those technologies here in the United States. So improving the manufacturability of these next generation technologies, as well as improving supply chains so that we can be producing that here. And supply chains really matter. I think that we're going to see a number of supply chain challenges. We're already starting to see them in some areas in this new COVID-19 world. You see it in terms of toilet paper of all things. And so supply chains are really, really important. And what matters more than anything is the diversity of supply chains. So that's something that we are taking very seriously, and we've been taking seriously for a while at the Department of Energy. So my office, Energy Efficiency and Renewable Energy, we are trying to contribute in a number of different ways in looking at new battery chemistry for stationary sources, for things like buildings, or for mobile sources for vehicles, as well as looking at, with renewable technologies, the integration of battery and wind, or batteries or storage and solar, looking at using hydrogen as a storage medium for long-term storage, and the idea of a hydrogen economy, as well as thermal storage technology. Really, the future of energy is a future of energy integration, and storage is sits at the center of what that integration can really be, as well as we admit to cheating a little bit about when we think about energy storage to make sure that we're including building technologies that increase the flexibility and resilience of the electric grid by changing how buildings use energy to be more flexibility, to be able to time shift, whether they use preheating or pre-cooling buildings. That's not technically storage. However, to the electric grid, it looks a lot like energy storage and can lead overall to a more efficient energy grid. So R&D, supported by my office, is looking at these hybrid systems, looking at a whole bunch of different technologies, looking at improving controls, integrating solar and into buildings, into large scale applications as well. So we are very excited about the potential for energy storage in the future. I encourage you to make the most of this opportunity presented by this webinar and for upcoming workshops. We want to hear from you, both through these workshops as well as through our upcoming request for information. As ever, we are here to, we need to hear from you. So please reach out to us. Let us know what you see as the future of energy storage and how we can help drive that future and help it become a reality. Thank you very much.
And now we'll hear from Bruce Walker, Assistant Secretary for the Office of Electricity. Bruce?
Thank you very much. Can everybody hear me?
We can.
All right, excellent. Well, thank you for this opportunity to speak today on this very, very important issue. As everybody, I think, understands, given this grand challenge, energy storage is a priority for the department as it presents, unique opportunities to improve our resilient and reliable energy system today and as we roll into the future. And honestly, as a former grid operator myself in my 20+ years in industry, I'm keenly aware of the opportunities that grid scale storage provides, and I wish I had it when I was sitting at the desk. While the benefits of energy storage are wide and encompass many very specific things, one of the key areas that we're looking at is how it provides support for our nation's critical defense facilities and the associated defense critical electric infrastructure, which DOE and my office, the Office of Electricity, has been working on as a result of the Fixing America's Surface Transportation Act that was promulgated by Congress in 2015, and how that ties together to really ensure the economic security as well as national security of the United States. Storage is critical in supporting grid operations, including managing variable renewable resources. Battery technology can provide enhanced functionality that increases the grid resilience, particularly in the face of adverse events and things that we've seen and highlighted in the 2019 Worldwide Threat Assessment that we filed with Congress, as well as the additional and increased deployment of intermittent or variable renewable generation. Batteries are a strong enabler of resilience and variable generation, really because of the versatility, our expectations that, particularly through the work of this team, the costs will decline. And we also believe that while we're decreasing costs, we can improve our performance. And lastly, again, going back to my roots, the storage provides unique services to help the overall operation of the grid, including, but clearly not limited to, voltage control, frequency control, and something we've really spent a lot of time recently looking at is the Blackstar capabilities, not only from a source but also as a sink, a load. So clearly an area where we're focused on from an operational perspective. DOE itself looks to integrate its entire strategy to position us, based on all the things we're doing within this space as the world leader. And we want to be able to really scale this from the lab to the marketplace, which is very much focused on some of what you'll hear the team, Eric and folks talk about this afternoon, as we move towards this domestic manufacturing capability. And I would just note that just this morning, the president signed an executive order called Securing the United States Bulk Power System, which I believe will help enable us further this grand challenge, capabilities as we move forward, specifically as we look to maintain or establish, maintain, and deploy storage capabilities throughout the United States and then, the rest of the world. One of the major components, which you heard the Undersecretary speak about, is our grid storage launchpad at Pacific Northwest National Lab, which will accelerate and validate our storage technologies. I am extremely excited about this partnership with P&L and industry to help drive this process forward. And in fact, there is significant funding that was included in the President's 2021 budget to build upon what was appropriated for this project by Congress in the FY 2020 budget. So, we are moving out on this in a very fast and focused way. And so, something that will come to fruition. I also am concerned that we need to increase our research and development on technologies such as non-lithium-based solid-state batteries. And another area that focused on is the development more broadly of the solid-state technologies and capabilities. Because as we move forward, I believe this is going to be, my team believes it's going to be an enabling technology needed to truly gain the maximum value of storage. So, that's another key area that we need to weave into this process. And, none of this gets done without people. All right. So the workforce development component, I think, is a critical component so that we develop and train the next generation of our workforce to be able to include all of the supply chain value streams that are enabled by storage technology. And, all of this comes together and requires really bold action. As you heard Alex talk about earlier, Secretary announced it early this year. And we have support through all venues within DOE, just by, I think, illustrated by the participation this morning on this call by some of the leadership. There are a lot of stakeholders in this, and we need to work through those to make sure that we've got all of the best and brightest minds in the United States taking a look at this, hence the conference today. What I would lastly like to say is, your engagement is integral in framing our strategy around how to address stakeholder concerns, support the end goals that we've laid out. And I know that there's been tremendous amount of work done by the team pulling this together, very thoughtful work, in-depth, comprehensive and complex integration of a lot of pieces of information and a lot of strategies to enable a strategic way forward. So I'd like to thank you for your participation today, and please be proud of the contributions that you're making to this really critical project. Thank you.
Thank you, Bruce. Bruce is going to stay on to see if anybody has any questions, maybe answer a couple of questions. If you would like to submit a question, please put it in the chat box and send it to the host. And while we wait for some of those questions to come in, as we get ready to listen to our panelists, I want you to know that you can also submit questions while our panelists are speaking. We are going to hold those questions until the end, so please include either the speaker's name or the topic when you submit your question, so we will have that for quick reference later on. So again, you can submit your questions to the host in the chat box. I'll give it just a moment here, Bruce. All right, not seeing any questions come in. Oh, wait, here we go. Bruce, can you please clarify how you envision the role of non-battery technologies, e.g. thermal, mechanical, chemical storage for long durations?
Sure. Again, I think when people speak of storage, and a lot of the work we do is bidirectional storage, but obviously storage comes in a variety of different forms. I think that all of them have a place in our overall energy infrastructure, even beyond the electricity system, to ensure that we're optimally using energy. So I think that all of those forms that were listed, among other ones that I know that we're doing R&D work on, and I know Daniel's group has significant efforts in this arena, are critically important as we move forward as well. So it's very comprehensive. There is no one size fits all. I think there's a lot of different capabilities that we need to deploy and focus on as we move forward to address this on a broader scale across the energy infrastructure.
Thank you. Another question: does Department of Energy expect to issue grant funding opportunities for electricity security?
I think those are decisions that will be made as we move forward through not only some of the grand challenge work, but other initiatives within the department. So none that I can point to today, but we're always talking about different opportunities to engage our stakeholders, engage industry and the private sector to move us forward, particularly in the security space.
Okay, very good. We've got some other questions coming in, but I think a lot of those are going to be addressed as our panelists speak. So at this point, Bruce, thank you so much for joining us. We really appreciate your time today, along with all of our other speakers. At this time, thank you. We are going to hand it over to Eric Shea from the Office of Electricity, and Eric's going to take us through the track. So as a reminder, you can submit your questions as we go through. Just make sure to reference the speaker or the topic. So Eric, I will hand it over to you.
Great, thank you. And as these slides come up, I'll reiterate, and you've heard already, that the Energy Storage Grand Challenge is a result of two premises. First, storage is important, and storage defined broadly, not just batteries and reservoirs, but the portfolio of technologies that achieve storage-like functions. And the second premise is DOE has room to improve in terms of coordinating across offices. The department has a range of world-class capabilities, and while our objectives may be aligned, our execution can sometimes be better aligned. What you're going to see today is an outline for a strategic plan of how to use all of DOE's capabilities, our convening authority to data-driven insights, to the ability to pursue long development horizons or address technology risks. And this plan will address how to arrange these capabilities logically to accelerate the technology industry. So you'll hear about the strategic plan from the 5 tracks: technology development, manufacturing and supply chain, technology transition, policy and valuation, and workforce development. But for anyone who needs a condensed version, whether you're an inundated executive or an impetuous millennial, here's our too long didn't read summary in 6 words: innovate here, make here, and deploy everywhere. So with that, I'm going to go into the first track, technology development. We want an R&D ecosystem for U.S. energy storage innovation, and we need to proactively coordinate with both within and outside DOE. And we will succeed when we see accelerated innovations resulting in greater performance at lower costs. So here's technology development and how it fits within the ESGC mission arrow. Technology development is focused on the innovation portion, innovate here, but successful innovations depend on understanding deployment. So we'll get to a DOE-wide R&D framework through 3 groups of activities. The first is developing and maintaining a set of guidepost use cases to help align R&D across a wide variety of offices. The second is assembling a diverse technology portfolio. And the third is augmenting the pathways that accelerate new technologies. And I'll go into detail on each of these. So our challenge is creating a unifying R&D framework for everything from sodium-based flow batteries to concrete thermal storage to rail cars on the hillside. So how we're doing that is to start with what benefits the end user, whether it's a home, a town, a business, or a region. And then with functional requirements, any technology can make the case that R&D can help it achieve these goals. And then we assemble a technology portfolio, technologies that have the potential to make substantial progress on cost and performance by 2030, and identify pathways, especially the DOE resources, whether they're consortia, partnerships, test facilities, or programs that will be utilized to accelerate each technology. I'll talk about the 6 use cases that we've assembled up to this point, how they hint at what could be possible by 2030, and how DOE can help foster a robust U.S. energy storage industry. The first is facilitating an evolving grid. And drivers for this use case could include aggressive decarbonization goals or transitioning from a world with steady load growth everywhere to more pinpoint investments. Now, as you can see on the right, there's literature already to what values for these uses might exist today, and there are some estimates that posit that values for seasonal storage are 80 to 90% lower than storage prices now. But given how battery prices have fallen over the last 10 years, a similar target might be appropriate for the next 10. One of the use cases where hybrids will be key could be in serving remote communities. This is in island, coastal, or remote communities. The applicability to a small coastal village or isolated mountain town might initially be limited in the U.S., but it does exist more commonly elsewhere in the world. U.S. growth could come with emerging goals like Oregon's 2-week READY program. They're looking to get 250,000 homes ready to survive for 2 weeks without critical services. While electricity generation isn't explicitly part of this program now, it could give the R&D community a long-term target. One of the largest use cases by market potential is electrified mobility, which includes onboard storage and the related charging infrastructure. Any non-trivial electrification is going to be a major draw on the grid. Level 2 charging today is around 10 kilowatt, but extreme fast charging is in the 300 to 400 kilowatt power range. One of the unique performance requirements here will be buffering the potentially spiky demand from extreme fast charging. Interdependent network infrastructure includes other infrastructures on which the grid itself depends. With dispersed or unattended locations, these facilities already use technologies like fuel cells to provide 8 hours a day to several days of backups. And one of the things we'd like to investigate, are there other technology pathways that could eventually provide co-benefits? Critical services resilience includes end uses that are important for life or mission safety. Most common solutions today incorporate a diesel genset with duration requirements for on-site fuel derived from the NFPA. Some examples include duration requirements from 24 hours to multiple days for hospitals and living facilities. The status quo isn't necessarily ideal since fuel can age over time and emissions limits can cap the annual runtime to 100 hours. So are there pathways to economically viable technologies that can provide equivalent or superior functionality without current disadvantages? Finally, the last use case is divided into 2 parts. Flexibility for smaller end users like residential, commercial, and flexibility for large facilities that use or generate power. There are value propositions and market values today like increased comfort or demand charges. And part of our stakeholder process, as well as with the policy and valuation track, is to draw out what these values might look like in 2030. So to take a macro view, these 6 use cases, hopefully broadly representative of what storage could do by 2030, might represent $6 to $20 billion in annual CapEx by 2030. Making some reasonable assumptions about business unit size and conversion ratios for R&D, there might be 50 or 60 companies or business units, each with a field demonstrated technology that had some support behind it. These technologies would span the gamut from bidirectional electrical, chemical and thermal, and flexibility solutions. Each of these technology pathways would traverse a progression from foundational science to wide bankability. And for the third group, this is what we mean with technology pathways. So DOE has a wide number of facilities, consortia, and programs to move technologies from the foundational science to wide bankability on the y-axis, and from materials and components to integrated operational systems on the x-axis. So as an example, this shows the electrochemical storage capabilities that the Office of Electricity supports. So hypothetically, if you're a postdoc with an idea for a new battery chemistry and your funding only allows you to build watch battery-sized prototypes, then the planned Grid Storage Launchpad at PNNL can help validate that that chemistry's performance would work well for the intended use case without needing to build $1 million test system. Let's say those tests turn out well, and you've received follow-in funding to transition to full-size pouch or cylindrical cells, and you want to test to make sure that they don't vent, leak, or burn. Then Sandia can help with BMS integration and subject those cells to aggressive or accelerated cycling at their battery abuse testing lab. Then after those tests turn out well, GridC at Oak Ridge can help verify that the integrated power conversion equipment will interact well on the grid. And finally, you've received startup investments and you're ready to make that first sale to a utility. I need to validate that your overall system will talk nicely to the utility SCADA. That's one of the envisioned roles for the Energy Storage Research Center. This example is meant to be just one of dozens showing how DOE capabilities with industry can establish an ecosystem that accelerates storage technology development. Having a pipeline of innovations will in turn help achieve the ESGC goal of U.S. energy storage leadership. So to recap, to accomplish the mission of maximizing the pace of storage innovation, the technology track will pursue activities in 3 areas: developing and maintaining use cases, assembling a diverse technology portfolio, and augmenting the development pathways. In summary, by strengthening the connections between all R&D stages and end user benefits, the Energy Storage Grand Challenge aims to accelerate the entire storage innovation process. And now for more details on the Make Here part of the mission arrow, I'll turn it over to Diana Bauer.
So I'm going to talk about the manufacturing and supply chain aspects of the Grand Challenge. So first, the purpose is to build a diverse and strong domestic manufacturing base with integrated supply chains to support our storage leadership. And we want to feed into the building of a robust manufacturing enterprise that drives down costs and also integrates and scales innovation. And finally, reliably sources critical materials and components. So to do this, we're pursuing these 3 areas: the addressing technical barriers to lower cost and improve performance, accelerating manufacturing scale up, and enabling reliable sourcing of critical materials and components across supply chains. So as Eric stated, this track of the Grand Challenge is focused on Make Here. So we want to accelerate the scale up, reduce cost, and ensure resilient supply chains. But also want to point out that actually it's a lot more complicated. That was a kind of simple figure, but this is as we think about scaling up, we kind of cycle back and forth between the more developed, the higher TRL level technologies and the need for innovation at the lower TRL level. So as we produce at a larger scale, we do need, in some cases, to return to the bench and come up with new innovations. So in the manufacturing scene, we think about that back and forth between innovation and manufacturing, and that's very important. Another contextual issue is thinking about the supply chain. So in order to have domestic manufacturing, robust domestic manufacturing, we need to think across the supply chains from raw materials to refined materials to manufacture of components, to integrating the system, assembling storage systems. And then, of course, those go to the end user. And then at the end, we'd like to transition, advance recycling. So in terms of how we're thinking about the R&D areas in this, across the supply chain, manufacturing process intensification, so that means substituting, simplifying the manufacturing process. So in some cases, you may have multiple processes that can then distill into a single process or a smaller number of processes. Critical materials processing and separations. One of the opportunities for enhanced domestic leadership is advancing to the next innovations in critical materials processing and separation. So, for example, production of lithium in using advanced chemistry in an environmentally sound way that can help us solidify our supply chain for lithium for batteries. Roll-to-roll manufacturing capabilities are important for producing membranes and other battery components, membrane manufacturing. Also new materials for harsh service environments. That's particularly important for thermal storage systems. And so on the right there you have a list of technologies aligned with the technologies that Eric covered earlier. So in gathering the information, gathering a foundation for the roadmap, we held a webinar in mid-March and had some breakout sessions to examine possible gaps and opportunities for us to pursue in the manufacturing side of this grand challenge. So we had breakout sessions on electrochemical energy storage, flow batteries, chemical energy storage, thermal energy storage, and industries as storage. So the industries as storage kind of corresponds to one of the use cases that Eric described, flexible operations in industry. So across these breakout sessions, some cross-cutting challenges were identified: membranes, bipolar plates, hybrid systems, grid integration technologies. So getting to from a storage technology to a system, including conversion technologies. So and power electronics are very important there. Raw material availability, so that is lithium and cobalt, vanadium also came up. And finally, translating the low TRL innovations to high TRL prototypes along the lines of what I discussed earlier. So in terms of what we're thinking for the roadmap, we have, as I mentioned, addressing technical barriers in manufacturing, two aspects: lowering the manufacturing cost and then reducing manufacturing barriers to improve performance. And so you see some of these items that I've just mentioned under each of these. And then in terms of the actions, we're continually performing technology assessment studies to further sharpen our understanding of where the opportunities lie, where the barriers lie, where the opportunities lie. And then we're investing across multiple offices for improved performance and lowered cost across the supply chain for manufacturing. And then in accelerating manufacturing scale-up, we're trying to accelerate the transition from innovation to commercialization. And for a scale-up, we're focusing on thermal storage, lithium-based batteries, and grid-scale deployment. The title of this slide should be Critical Material Supply Chain Resilience. And in this case, we're particularly focused on fragmented supply chains for lithium and cobalt in batteries. And we're focusing on R&D on lithium processing and separations innovation, R&D on batteries with reduced cobalt requirements, and then also innovations in battery recycling. So I don't think it's been mentioned yet in this webinar, but we plan when we issue the draft our roadmap for comment, we will also issue a request for information. And so on this slide, I have some a preview of some of the types of questions we'll be asking. So ranging from what are some pressing challenges for scaling up various technologies, what are some barriers to lower cost, and are there some other policies that would help establish and maintain a manufacturing capacity within the U.S. And that's the end of my remarks. And now I'll hand it over to Steve Hendrickson to cover tech transitions.
Thank you, Diana. Hi, everyone. My name is Stephen Hendrickson, and I'm a program manager in the Office of Technology Transitions at the Department of Energy. And alongside my colleague, Marcos Gonzalez-Harsha, we've been leading the tech transition track for the Grand Challenge. As Deputy Assistant Secretary Fitzsimmons said, R&D is necessary but not sufficient for the U.S. to lead in energy storage. So what our track is focused on is how to strengthen U.S. leadership in energy storage through the commercialization and deployment of energy storage innovations. That largely focuses on, I'd say, three areas: the financial dimension and how to get the necessary investments to develop and deploy energy storage technologies, providing the marketplace and stakeholders with the necessary information to make informed decisions, and really understanding the nature of current and projected markets that those energy storage technologies are going to compete in. So our focus as a track is really about outwardly facing and thinking about how to engage with necessary partners in the private sector, other organizations across the federal government complex to support the demonstration and deployment of those technologies. And so what we'd like to share with you today is just some of our initial framing for what those challenges look like and how to address them. And what we really would like this to be is the beginning of an ongoing dialogue and engagement with the range of those of you on the webinar today and others to understand how you see things playing out in the marketplace and how that can inform our strategy to be as robust and flexible as possible. So returning to Eric's framing of innovate here, make here, deploy here, I think a couple points to make is one is we think it's important to expand the innovation pipeline early stage so that you have as many different technologies being developed as possible, so you have a diversified portfolio of options that can then flow into those use cases that were identified. So that includes both government R&D investments, but also early stage private sector investments into those technologies to commercialize them. I think when you look across innovate here, make here, deploy here, it's important to note that there are relationships between where the innovations take place in that early stage R&D with where the manufacturing takes place. And as Diana highlighted, there's a lot of innovation going on in that manufacturing component, and really understanding how investments in both of those areas can complement one another to support U.S. leadership in manufacturing energy storage technologies. Similarly, where manufacturing will be located is also connected to where deployment is occurring. So we're trying to understand both domestically and internationally where will be the demand for those energy storage technologies and what implications that has for where investments are going to be in manufacturing. So a couple high-level points just to make is that we're looking to leverage a full suite of federal government tools and resources to enable U.S. firms to compete in markets around the world, and that the build out of companies that are producing that equipment and developing those projects for steel on the ground is going to require significant private sector investment. That the government can lead and develop a strategy, but we're really looking to the private sector. So when we think about what it means to commercialize these technologies, what I think it's helpful to return to the 6 use cases that Eric identified of facilitating an evolving grid, serving remote communities, electrified mobility, interdependent network infrastructure, critical service resilience, and facility flexibility. And I think the point there is that to really understand what it means to commercialize the technology, you need to think specifically about each of those use cases and identify what are the markets you're talking about, who are the actors involved in each one of those use cases, what are their needs, and then what are the tools and capabilities that we have available to us to support that deployment. So if you're thinking about for facilitating an evolving grid, it may involve an investor-owned utility, a cooperative, a public utility commission. That's a different set of stakeholders than if you're thinking about electrified mobility, which may be more about vehicle manufacturers and commercial and individual customers who are making investment decisions about like what kind of vehicle they're going to buy. And so we need to be very precise and nuanced in how we understand those different markets so that we can tailor the responses appropriately and maximize our chance for success. With regard to innovate here, I think there's sort of 4 stages or 4 layers of what the role of finance and investment in that space would be. The first is, as I mentioned, investing in a range of early stage technologies. So we have as many options as possible. Then you reconcile that with the use cases that we've laid out, and then sort of an iterative process where you see what the technologies are capable of. Then you look at what the use case needs are, and you make sure that the technology can meet those needs, or as new technologies emerge, new use cases and options for how that technology could be deployed are refined. With that in mind, you then think, well, if a company is going to compete in that space, what are the viable business models available to them so that they can ensure predictable revenue streams that will be sufficient to attract investment by investors that are looking to get a sufficient return by supporting that company, and really understanding that company's viability is thinking about, well, what's the broader market that technology would be competing in, that company would be competing in. As I mentioned, the commercialization and deployment is going to require significant private sector investment. And I think one point we want to make is that there are different risks associated with the type of activity that you're completing. So, for instance, if you're developing a project, you have risk associated with project development. So, if say you have an energy storage grid solution, you have risks associated with building a physical asset in a given location on time, with the equipment arriving on time, with the permitting being available. Those are all risks that pose financial challenges that can be addressed. A different type of activity that's necessary for us to succeed in this grand challenge is the manufacturing risk. If you're a company with an energy storage technology that is looking to compete in that space, you have different risks associated with, can you build your factory on time? Is the product going to perform the way you expect? Is the market for that technology going to be there so that you're generating sufficient revenue to be a viable business? And those are different from developing a specific project in the ground. Thirdly, the overall marketplace is another set of risks. Where will the markets for energy storage emerge, both domestically and internationally? Where are they today? Where are they headed? What are the sources of uncertainty associated with each of those markets? And so the point here is that we need to have a nuanced approach that addresses different types of risks and complement one another to have an integrated strategy to address those various challenges. And then finally, sort of building on that, deploying everywhere, we need an integrated strategy that leverages the range of federal tools to enable U.S. firms to compete. I think, as I kind of laid out, we have varying use cases that each will have its own technical and cost requirements, and we need to be sensitive to what those are. We need to be thinking both in terms of domestic and international markets. And we think that having a multi-pronged approach to look at numerous markets, numerous use cases, and seeing what are the options and what's the possibility that that will be a sufficient market to support U.S. leadership are, we need to be thinking about that now and then iterating over time as we see how these markets evolve, and to be sensitive to the numerous decision makers that are relevant to each one of those markets, from customers, investors, manufacturers, entrepreneurs. And so with that in mind, we've laid out 10 activities so far that we've been pursuing, some very specific, connecting labs experts to external partners. As Diana mentioned, my colleague Rima Weed is leading on a request for information where we want to solicit your and others' input on the strategy so that we can refine it and improve it. The department runs a lab partnering service that can be visited at labpartnering.org, where you can search out via keywords subject matter experts, intellectual property, and user facilities that can be utilized to support energy storage commercialization and development. We also have mechanisms such as a technology commercialization fund, where the department has set aside specific dollars that are intended to help commercialize technologies coming out of the national labs. That's highly relevant to the Grand Challenge for Energy Storage. We're also pursuing projects where we're helping the national laboratories to find innovative ways to pursue commercialization. And then I'd say at a sort of higher level, we're also just sort of broadly thinking about, well, what are the real world projects we can develop to demonstrate the technology? How can we collaborate with industry to make those happen, to identify those barriers and address them? We've had a lot of great initial conversations with our interagency partners, from the USDA's Rural Utilities Service to the Department of Commerce, International Trade Administration, the Export-Import Bank, and others, on ways that their mission is to support U.S. Corporate leadership or economic leadership, both domestically and internationally, and we can kind of connect that with our technology innovation agenda to be mutually reinforcing and to build those collaborative relationships. And then finally, working with a couple of my colleagues, Hugh Ho and Catherine Harshani here at the Department of Energy, on a market and industry analysis that will provide both internal to the government and to the public high quality information about the status and projections for where the market's headed, to inform decision making and accelerate investment decisions. So with that, I just want to highlight, here's my contact info, steven.hendrickson@hq.doe.gov. I'm more than happy to connect you with others across DOE and take your feedback and input. And we hope that this is the beginning of a conversation about how we can improve this strategy and identify opportunities to collaborate. So with that, I will pass it on to my colleague, Alejandro Moreno, to talk about policy and valuation. Thank you.
Great. Thanks, Stephen. I'm Alejandro Moreno. I'm the director of the Water Power Technologies Office in EERE, and along with my colleague Paul Spitzen, we've been leading the policy and valuation track. As Alex said this morning, we recognize that in order for DOE to leverage all of our resources to really drive optimal use of energy storage and drive the industry forward, we need to do more than R&D, and certainly that's the genesis of the policy and valuation track. Recognizing that a lot of the decisions that will be made over the next 10 years that determine the course of energy storage and certainly determine whether or not it is developed and used in a way that provides the most value are going to be made by people that don't necessarily have a role in an individual technology or even an individual project. And specifically by bodies involved in policy, regulatory decisions, and in planning decisions. But we recognize that many of those decisions right now are not made with a full suite of necessary information, or the level of granularity or sophistication in the modeling tools and analysis that are required to make the right decisions don't always exist. And so DOE's role, and I'll give this caveat a couple times, of course, it's not our role to recommend or set specific policy, but it is our role to make sure those who are developing policy or making regulatory decisions have the information and the tools that they need to make the decisions that are best for them. And so, policy, of course, and regulation, of course, affects everything. And there's innovation and R&D policy, and there's manufacturing policy and industrial policy that drives many of the goals you've heard about already. But probably the most obvious and largest suite of policy and regulatory options, and certainly where valuation really comes into play, is in the utilization and the deployment. I would say that this is, of course, not just a unidirectional arrow. It's really a circle. And if you develop regulations and policies that encourage the optimal sizing, optimal capabilities of different technologies, different energy storage technologies, then of course you're also encouraging innovation in those capabilities that offer the greatest value. The decision makers that largely we're focused on are here, and probably that top row are those that are most critical and are most likely to make decisions that really are going to determine the course of the storage industry or those various technologies, and specifically public utility commissions in the states, ISOs and RTOs, and FERC to an extent as well, state legislatures, state energy offices, those setting large state mandates that can encourage or in some cases not encourage different technologies deployment, and utilities, particularly in the planning section of utilities, ensuring that the tools and regulations are right. And if information is not fully accurate or is not fully available on those bullets on the top there on what storage can do, and particularly what different chemistries can do under different operational strategies, under different conditions, for example, and what storage worth, and ultimately how do you end up paying for it, then you effectively are operating with your hands tied behind your backs. And we hear that, for example, from a lot of utilities when you look at storage as integration in IRP processes, for example. It's very clear that they don't have the tools to truly understand how different storage technologies would be used under different scenarios. And so you end up with a paradigm where, on the one hand, utilities are often saying, well, we want to be as flexible as possible, so we'll get a lot of storage, or we'll have a storage target internally. Or on the other hand, we don't have the sophistication that we're comfortable with, so we're not going to even go there at all. And those are the situations that we're ultimately trying to avoid. And so some of the key issues that we're focused on, the first is resilience. I think we all are very comfortable with the notion, as Bruce said earlier, that storage is potentially a critical tool in improving the resilience of the grid. And here, since resilience can mean a lot of things to different people, to clarify, I'm talking about both the prevention of and response to low probability, high impact events. But what we do know, because resilience can mean different things to different people, is that there needs to be a little bit more rigor in being able to draw the line specifically between a resilient system and the individual devices and the properties of the individual devices that comprise that system. And understanding how different characteristics play as part of a portfolio with each other, different technology characteristics or attributes to create overall resilience. For power system operations, certainly understanding that a lot of storage technologies and the capability embodied there are not well reflected in power flow, system stability, and dispatch tools. For energy system planning, same thing, probably even more so, recognizing that storage isn't necessarily well represented in capacity expansion models. Also, the relationship between DER, bulk power system, and some of the different investments that you have there, and how where the value trade-offs lie, and that leads to some of the situations that I just mentioned before in the previous slide. And lastly, the transportation and cross-sector, and this is where it's important to recognize that the storage isn't just a grid technology. It certainly is energy storage is critical for some of the advances we've seen in mobility, and there's a really close link between storage for mobility and storage for the grid, both very direct, things like fast charging systems, but also in future planning and understanding how storage can provide value, effectively cutting across and translating between some of the use cases that Eric talked about this morning, between the transportation sector and the industrial sector and the grid, for example. So what's DOE's role here? As I said earlier, it's not to recommend or certainly not to set policy, but it's not really even to recommend specific policies, but it is to provide those decision makers that I showed earlier with the information and the tools that they need. We do some of this already, and I'll show that on the next slide, but the genesis and really the philosophy behind the policy and evaluation track here is to embody that need for better coordination across the different offices that Eric talked about, and that really is one of the drivers of the Storage Grant Challenge. And we know that in order to be effective, this type of support, it needs to be targeted. It needs to be targeted at those issues that are most critical and most likely to prevent the optimal use or deployment of storage. It needs to be systematic in the sense that it's addressing each of the particular barriers that prevent or that stand in the way of a particular use case or a particular decision. We can't just respond to what's easy or what we have the capabilities in front of us to do. It needs to be coordinated, again, across the multiple different offices. We want to make sure that we are both leveraging the expertise that we have in building, but we're also avoiding providing different types of information from different offices to the same stakeholders. And also, of course, it has to be informed and objective. It has to be the work and the support that we provide directly to decision makers needs to be informed by our analysis. And it needs to be objective in the sense of not being technology neutral. And of course, as many people on the line know, DOE is really that we are structured by technology, usually the R&D. So I do hydropower research, my colleagues do solar research. And if our technology or our support is seen as coming from just the solar office or just the hydropower office, often it's going to be interpreted or actually unintentionally biased as support of a particular technology rather than the overall grid. And so you can imagine something like this, where we've identified some of the key foundational needs, and those include better data, particularly field-validated data, better models, as we've talked about, that use those data, and cutting-edge analysis that helps us understand some of the questions about how different storage technologies could be sited, located, used, combined, and really where the value drivers are, because obviously the value is going to differ by the characteristics of the power system and how we see it evolving. And really those arrows that feed up should be bidirectional. I'll talk about that in a second. And also the fact that these are individual categories here, PUCs, ISOs, et cetera, in no way implies that those are monolithic groups. There's very different priorities and needs within each of those groups, and often a lot of synergy across multiple groups there. Very quickly, this is some of the work that we're already doing and continuing to build up. Rest assured, we're not starting from scratch. Many different offices have storage regulatory engagement and storage analysis. What we did find is that often, for example, the work in OE and the work in EERE, and sometimes the work between different offices in EERE didn't always talk to each other, and sometimes the regulatory support, so the actual technical assistance projects, were not always informed by all the analysis that was going on in the office. There is a lot of work to build on, but a lot of the work that we're going to do in the policy and valuation track is drawing those linkages and helping prioritize the issues across each of the individual stakeholder groups. And so ultimately you end up potentially with something that looks like this, where you have a clear strategic impetus and strategic prioritization of issues in resilience, in power system operations, energy planning, transportation, that are the most critical issues that are the overlap in the Venn diagram of those that are the most critical issues for each of these stakeholders, and those where DOE and the national labs really have the capability to be able to support. And this support is delivered through a trusting, deep relationship between DOE teams and the individual decision makers, where we are able to provide the analysis and ensure that it's best targeted for decisions. So it's not just reports sitting on shelves, but just as importantly, we continue to listen as those priorities evolve, because as the grid evolves, the one thing we know is we do not know everything right now. We do not even know all the questions that will be relevant in 2 years, in 3 years, in 5 years. And so ensuring that we continue to listen to each of the stakeholders, each of the regulatory and policy decision makers, understand what they need from us, and continue to tailor and adapt our research, our analysis to meet those needs, and to help ensure that storage and the group of technologies that embody storage are deployed, cited, and used to maximize their value, and so that value can ultimately be compensated and incentivize more development. So with that, I will turn it over to my colleague, John Vetrano, who's going to talk about the workforce development track.
Yeah, thank you, Alejandro. I'm John Vetrano. Let's see, we'll move to the next one. I'm at the Office of Basic Energy Sciences in our office. So my boss, Linda Horton, and then also staff the Advanced Manufacturing Office, Valerie Leitner, Diana Bauer, and Steve Spooner are helping work this. So in order for the Energy Storage Grand Challenge to succeed, we'll have to develop a strong and dedicated workforce as a key building block for this success. So for this track, we will focus DOE's programs to fill the pipeline of personnel needed to implement the goals of the ESGC, trained in everything from machining to mechanical engineering to material science. So the three, innovate here, make here, deploy everywhere, workforce development, as you might imagine, spans all three of the components of the ESGC. This requires a wide scope of workforce development programs. So the department has a long-standing interest in developing a workforce that will meet the specialized needs in the energy sector. Therefore, there are a wide range of existing programs and program modalities that either are or can be focused on energy storage. The Office of Basic Energy Sciences, for instance, supports over 2,000 graduate students each year, as well as a large number of postdocs and undergraduates. Additionally, offices such as the Energy Efficiency and Renewable Energy leverage a wide range of their consortia, laboratory projects, and universities to enact a variety of hands-on workforce development programs. So this is an illustration of the breadth of the existing workforce initiatives within the department, some of which, like the Energy Storage Internship Program, are already focused on energy storage. So right now, we are seeking to assess these programs with respect to energy storage workforce needs. Then we will look for opportunities to focus or grow existing programs and initiate new ones. So for Innovate here, we will require a strong base of scientists and engineers to develop new products and push them towards commercialization. DOE will support research in energy storage that will grow and strengthen this cadre of workers to help develop the energy storage systems of the future. To build here will require engineers, welders, designers, and more. DOE will support programs that will help develop these specialized skills that these people will need to create and build energy storage projects. To deploy everywhere will require broad expertise in siting and building installations, but also analyzing entire systems to optimize the use of energy storage for grid efficiency and resilience. For our activities, the workforce development track will consist of several activities to achieve these goals. First is seeking stakeholder input through the RFI that Diana and Stephen mentioned to better understand where there are strengths and gaps in the existing and the potential future workforce. So for these things, we will want feedback from the people on this webinar and the people who attend the other ones as a response to our RFI. Then we will also assess the efficacy of our existing programs and seek to understand the balance of the needs with the skills development required. DOE will also seek to make better connections across offices to identify synergy in workforce development programs, similar to what Alejandro was saying earlier. So this is just a quick summary of what I presented for you in the workforce development track of the Energy Storage Grand Challenge. Thank you very much for listening to this presentation. And now I hand this over to Meredith, who will get us started with questions from the audience. Thank you.
All right, thanks so much, John, and thanks to all of our panelists. So now we're going to open for questions, and you guys have been doing a great job sending questions to us. We already have a whole pile that have come in. We're sorting through those right now. And again, if you have additional questions, do reference the speaker or the topic. The first question I'm going to answer, which is, are the slides going to be shared? Yes. We are going to post a recording of this entire webinar, as well as a PDF of the slides. That will be up by the end of next week on the Energy Storage Grand Challenge website, and you can download it there. So let's get started here for our panelists. Alejandro, I am going to give you the honor of answering the first question, which is, there are a lot of questions coming in regarding funding around the Energy Storage Grand Challenge, funding opportunities, grants, FOAs. Can you address what that is?
Sorry, Meredith, you cut out at the very end there. Can you hear me? Can folks hear me?
I sure can. I sure can. So
the question. And I heard the question, and that was not a dodge of the question. Would have been a very, sorry, No, I think it's it's an understandable and it's the right question to ask. A lot of the work, as we talked about, that's going on in the Energy Storage Grand Challenge is being undertaken in the various offices, and so the funding decisions are made at the office level. As you saw in a lot of the policy and valuation work, a lot of this is going on already, and the work of the Storage Challenge is to better coordinate it. That said, of course, the fact that we and you've seen the level of priority from us and from everybody who spoke here today means there's really a strong focus on all of these topics and on technologies that can deliver storage, and each of the pillars that we have here today, the actions that you heard us talk about. And so certainly we are looking for ways to drive investment there and for topics that we can fund. Ultimately, our budgets are decided by Congress, and we have a new fiscal year coming up at the beginning of October, and so we'll see what the ultimate funding level for each of these is then.
Okay. Alejandro, one more for you here. Will DOE be coordinating closely with states, some of which have set aggressive storage targets, such as Virginia and California?
Yeah, this is very much a question for me that's smack in the stakeholder group of state legislatures and state energy offices that we talked about. So we're there to offer support. I don't think, as I said a couple of times, we're not going to coordinate in the sense of saying you should or should not adopt a particular policy decision. But certainly if a state came to us, if Virginia, for example, wanted to understand the impact of a storage mandate, either retrospectively or another state wanted to look at best practices, that's exactly the type of thing we'd both use our analytical capabilities to help answer, and also our convening power to bring different states together so that they can learn directly from each other.
Great, thank you. Stephen, the next question is for you. How are you applying the engineering consulting community in advanced energy storage? We might not be university researchers, but we know how to build systems from pilot plants to large-scale plants.
So that's a great point. Internally, we have discussed the engineering consulting community as an important set of stakeholders that have a lot of expertise. I think that's something to come. I would actually, if whoever asked this question feels comfortable, feel free to reach out to me directly, and I'd love to have a follow-on conversation about ways that we could best leverage that expertise. Again, stephen.hendrickson@hq.doe.gov. And it just shows that, yes, we want to bring in as many different perspectives as possible. So I appreciate the point.
Very good. Diana, what funding for private sector supply chain development is available, especially with regards to smaller or innovative critical mineral mining processing companies, which often compete with vertically integrated subsidized competitors?
Yeah, so thank you for that question. We are interested in supporting scale-up of innovations for separations and processing, early-stage separations and processing, and expect to have some opportunities coming in the next several weeks or months for that.
All right, very good.
Thanks.
Stephen, one barrier to commercialization for small startup firms is performance guarantees and warranties. Initial adoption of new technologies by private sector is dependent on a utility being willing to take a risk that a new technology will perform as promised. Would a long-term validation program that produces a quote-unquote good housekeeping seal of approval, like report similar to an independent engineer's report, fit with OTT's jurisdiction in the Grand Challenge?
I think it's a really interesting idea. I would say at this point we are, we're just collecting those ideas and thinking through, kind of going back to my part of the presentation, what are the current risks and what does that mean in terms of whether projects are getting developed or getting the funding they need, and what would be the impact of that kind of a mechanism. So I think it's definitely something we can look into.
John, to what extent could the workforce development pillar support a technology that uses incumbent or existing workforces with no need to retrain or relocate?
Yeah, thank you for that question. I mean, I would hope that if those people exist, then we would support that technology. So we're not focused on supporting a given technology, but making sure that there's a good sort of pool of resources in terms of personnel to be able to either step into a project or a program, or have things that will allow people to come up to speed quickly. So, so we're not specifically technology development, so I think that should work fine.
Very good. Eric, this question is for you. What energy storage metrics are currently being pursued by DOE? Are LCAT, LVAT being considered?
Thanks, Meredith, and that's a great question. As you could see in my my slides on the use cases, the metrics being used today on energy storage are all over the place. There's the levelized cost of energy that's more commonly applied to wind and solar resources, measuring the dollars per megawatt hour of output. There's dollars per kilowatt hour installed capex for storage energy capacity cost, and even there, like, I'm struggling to be precise about what I mean when I say those words. And I think there's really room to have a set of improved metrics that take into account the sort of the life cycle cost or cost effectiveness of an energy storage resource being used for a specific application. One of the places I would point to that most closely aligns with where we think these metrics would need to go is in the ARPA-E days solicitation from a few years back, and they had a levelized cost of storage metric proposed there that took into account cycle life and operational costs. And I think that kind of full cycle accounting or full life cycle accounting, or as close to it as you can get, is really going to help us be able to create clear R&D cost and performance targets across a variety of technologies. So thanks.
All right. Eric, I'm going to give this one to you as well. It's great to hear there are multiple ways to meet our energy storage needs. What are the thoughts of maximizing the use of natural gas storage to meet power generation, heating, and industrial energy storage needs?
So then there again, I think this is why it's useful for us to consider the use cases. We are looking for storage technologies that have the ability to be very flexible and be able to provide specific grid functions depending on the use cases. But in addition to just the sort of electrical engineering operational considerations, there are also more practical considerations. So I gave an example for the remote communities use case. Deliverability and shipping of the system and fuel deliverability is a major consideration. So we're fully aware that not all technologies will be a good fit for every use case, and that's why we wanted to have these use cases represent a broad spectrum of potential uses. So the short answer is, we're not eliminating any technology up front. We're trying to create a framework where any technology that has the capability or potential capability to fulfill all the functional requirements can be incorporated in this initiative.
Very good. Stephen's next question is for you. Will there be an opportunity in the Energy Storage Grand Challenge for small startups with creative new approaches and ideas to partner with lab staff for analytical support?
So my answer would be twofold. I think one, so as I highlighted, there's already an existing program, the Technology Commercialization Fund, TCF, where I think about 0.9% of every program's budget is already sort of earmarked to be funding lab activities to commercialize technologies to partner with a startup or some external company. So I think that would be something I would recommend looking into. In addition, we're definitely exploring other options to, further support that engagement between startups and the labs. And to the point about analytical support, I think emphasizing that is something we will look into as well.
Diana, innovations in battery manufacturing require retool and integration of extremely expensive capital equipment. How can groups access the supportive but limited infrastructure to validate them? Will there be proposals to fund manufacturing innovations in energy? And Diana, you are still on mute. Oops. There we go.
Can you hear me now?
I can.
We in the manufacturing office are working with the vehicles technology office on accessing the test facilities at the national laboratories to potentially provide opportunities for businesses to work with them to identify, or to scale up their new innovative manufacturing processes.
Eric, related to your slide on slide 24, the pathway example, how does DOE plan to work with industry where battery testing capabilities already exist in the commercial sector?
Yeah, that's a great question. One of the processes we went through in initially scoping out the grid storage launchpad was to do an extensive review of existing capabilities, both within DOE and in industry. And I'd like to commend the team at PNNL who embarked on this research, and thank all the battery facilities who allowed our teams to go and interview and in some cases visit. One of the things that we found was there is a distinction between testing for certification purposes. So you get you have met some industry-wide standard for performance or durability or flame resistance, for example. There's that kind of testing versus testing for R&D validation. So I've got a new chemistry. I just want to see if it works. And they are distinct functions or distinct objectives, even though some of the underlying equipment might be shared. And so I think one of the things we want to continue and probably improve on as we go forward is to have structures where we can have an ongoing conversation between our DOE facilities and capabilities and industry to say, okay, what is it that is most appropriate for DOE to help support in terms of buying down the fixed cost for testing and validation capabilities versus what it is that the private sector would take on itself. I think this is a much longer conversation, and it's probably going to have an answer that will evolve as the industry evolves. So yeah, great question, and I think the answer is it's going to be an ongoing process.
Okay. Stephen, can you address the timeline for the RFI that has been mentioned today?
Sure. I don't have a specific date, but we will post that. That'll be posted both in the Federal Register as well as on the Energy Storage Grand Challenge website on the Department of Energy website. The plan is to release it, I think, sometime later this month. And as Diana mentioned, that will be released alongside of the draft roadmap that we've been developing. So I encourage everyone to review both of those and provide input via the RFI.
Okay. Eric, how do you educate the utilities regarding fire hazard risk of lithium-ion and LFP battery tech?
Sure, thanks for that question. And I'd say within that question, it's not just utilities, but a whole bunch of other stakeholders like local zoning boards or individual end users need to be educated about the specific risks for all energy storage technologies. I think we are pursuing the safety testing capabilities as well as supporting efforts to develop best practices or industry standards for flammability risk or recovery from thermal runaway events. And in some cases, DOE also supports sort of ex post forensic analysis for certain events. So I think one of the best roles for DOE is to provide data-driven insights and analysis, and to support efforts and to give that to the industry to help them develop the standards and best practices to make sure all energy storage systems are safe for use.
Thank you. Alejandro, this next question is for you. It's a good idea to pursue a diverse set of technologies, but when just a few prove to be, quote unquote, the best, how will DOE narrow down the set of technologies that it supports, and how will it decide when to reduce or eliminate funding for non-promising technologies?
Sure. I'd say that's really probably a question for Eric, but I'm happy to take a first stab and hand it over to him. That's very much the philosophy behind use cases, and then sussing out from those 6 big use cases, what are the individual technology requirements that are needed to meet them. And so that effectively creates a framework, a technology neutral framework to evaluate both the performance of different configurations, different technologies in providing the different technical characteristics or attributes that are needed for those use cases, and then also in part through the analytical work that will happen in policy and evaluation, understanding under what situation or which capability is likely to be most valuable. And so by combining both the framework that Eric has put together and some of the data and the analytical tools that are forthcoming through policy and evaluation, we create a framework where we can actually do that. And it's certainly, the intention is not to continue funding every technology in perpetuity, regardless of how well it performs. But Eric, I'd hand it over to you. You may have more to add there.
Yeah, I think that's well said. I think conceptually the framework follows the R&D pathway that I'm sure all of those on the line are familiar with. We understand that there is, for any technology, at the outset, there is some high-risk basic research that needs to be done. And that's when the uncertainty is the greatest, and that's when, the federal share of support for that kind of work is also the greatest. As you get further down the technology maturity line, you start to have more certainty onto how well this pathway is going to progress, or like what's the range of the likely outcomes as you do more testing and do more research. And so I think what we're trying to set up is to match the technology potentials, like when we have some more certainty about them, with the end use as soon as possible. And that will help us, prioritize and identify the most promising technologies.
Stephen, this next question is for you. The pipeline development you were talking about applies to most hardware technology development. What programming and capabilities can DOE stand up to support small businesses commercializing this technology and extending their runway to the point that they are ready for private investment?
So I would say, the need to support small businesses that are trying to commercialize technology is important. And I would say I almost flip this question around and say, what we're seeking right now, we're discussing this topic a lot internally. Well, we'd love to hear it from people out in the sector, whether you're a small business, investor, technologist, whomever. Tell us through the RFI or through direct engagement, what are you seeing and what do you think would be most useful? And that helps provide, helps inform our strategy, and may lead to something down the road. But I think that's really what we're looking for, that input from people that are seeing this firsthand.
Okay. Last question for today. Eric, what is the role of companies like utilities in this effort? What is the role for companies who are not storage device developers themselves, but will partner to deploy the devices on the grid or combine with their own generation assets?
I think this question has three facets to the answer. So I'm going to ask Stephen and Alejandro to jump in after me with their perspective. But from the technology development perspective, utilities are going to be the partners or hosts for many of these use cases. And we'd like to get a better understanding of what your needs are. Like, how exactly would you use these technologies? What kind of performance do you need? from a range of technologies before they would be superior to what you have on your system already. So from technology development, getting an idea of what you need is the most helpful. And so definitely participating in our process this summer and ongoing is going to help us develop that roadmap. But for actual commercialization and valuation considerations, I'll hand it off to my co-leads.
Meredith, can you repeat the question, please?
I will absolutely do that. What is the role of companies like utilities in this effort? What is the role for companies who are not storage device developers themselves to participate?
Well, the role for utilities is huge. I agree with what Eric said, and certainly, ultimately, in many cases, utilities are either going to be procuring or developing projects themselves, and so being able, again, from what we've heard really consistently from utilities, is the need to have planning tools that capture this in a much greater level of granularity, the value that they're going to derive from storage writ large, but really from individual projects, because they're planning at a project level, is critical, and they don't have that. And as a result, they're, as I said before, they're not actually able to have the level of comfort in out-year planning that incorporates storage in a way they would like. And so we want to work really actively with utilities, and some of the storage technical assistance and analytical work that is already going on, we're looking at ways of expanding that directly to utilities. And certainly, as just from a policy and valuation perspective, if utilities, if anybody is out there from a utility and you're able to respond to the RFI with both some of the needs that you have, confirming or not the hypothesis that we have, and also the delivery mechanism that's most effective, I think that would go a long way in helping us target this accurately. Also a big role in demonstration projects, so maybe worth then turning over to Stephen.
Sure. I would just add to that, I think back to my point about, we're talking about a number of different markets. So if you're thinking about grid applications, I agree. It's about, what do utilities need to get a project approved, to get a PUC to approve a project, something like that. If you're thinking about transportation, then it starts to get, well, what does an original equipment manufacturer need to be confident in, using a given technology in their vehicle? Or what does a customer need in order to, if you're the customer and you're going in deciding between an internal combustion engine or an electric vehicle, you're making decisions based on a different set of criteria and information than a corporate, regulated utility, something like that. So I think really what will help us is to get a sense from the various, for those various entities that are deciding whether or not to choose the energy storage option versus some alternative, what are the factors that ultimately make that decision for them, and to say, well, what needs to happen to shift it slightly so that this energy storage option does make more sense than the alternative, and then what are the tools available from the department perspective, to whether it's analytics or financial mechanisms, what are the pieces that would be useful to shift that calculus slightly.
All right, very good. Thank you all so much for submitting these questions. We have a lot more that we would like to get to, but we are nearing the end of our presentation today. So before we go to our final remarks from Michael Passon from the Office of Electricity, I do want to give a quick advertisement for the rest of our workshops that are going to be held throughout the month. I've got a slide at the end here. We'll share the link, but you all will also receive an email after this webinar with the direct link so you can register for the remaining 4 workshops. Our next one is going to be on the use cases, and then we'll have 3 regionally focused workshops, one for the Pacific and Northwest, one for the South, Southwest, and one for the Midwest and Northeast. So right now, again, thank you all very much for being here today. I'm going to turn it over to Michael Passon, Deputy Assistant Secretary for the Office of Electricity, for our closing remarks. Michael?
Thank you, Meredith. Well, I just want to share some final thoughts today before we close this workshop. So first, I want to thank everyone for joining this. today, and I also want you to join me in thanking all the presenters. They did a terrific job covering all tracks of the Energy Storage Grand Challenge. So I saw we had almost 500 people joining today's workshop, and there was a lot of great questions. And for me, it shows there is good testimony to the importance of this topic, the energy storage topic. And I really hope that we manage to communicate that DOE is really serious about doing everything in our power to ensure that United States has leadership in the energy storage space. And as you saw, we are looking at the entire cycle necessary for the success. We want to innovate here, enable innovation. We want to make it here, enable manufacturing, and then we want to be able to deploy our products everywhere in the world. So that requires a lot of efforts from everybody. But with each of the tracks mentioned today, there come significant challenges. And those challenges require a diverse range of perspectives that will help us to form a holistic DOE approach with regards to energy storage. And the formation of the effective strategy that intersects with complex areas such as maintaining a reliable, secure electricity delivery system and supporting evolving electric grid, that is my Office of Electricity is focused on, or such areas as integration of renewables and mobile electrification that Office of Energy Efficiency and Renewable Energy is leading. All this requires knowledge from both sides, inside and outside of the DOE. Now, you know, the DOE has tremendous capabilities, right? We have a national laboratory system that is the world's most advanced capabilities. But even with all these resources, we cannot do it without your engagement and support. We need all of you working with us to help us succeed. And we need to succeed to make sure that United States becomes world leader in the energy storage space. Now, as part of our continued effort to receive input from stakeholders, we will have, as Meredith mentioned, a series of regional workshops that will be held, and we will discuss use cases, and this will help us to guide the overall strategy. Now, a request for information will be released, and that will have several specific requests for information for each track to help us to collect public input. Also, we will publish Energy Storage Grand Challenge Strategy Roadmap, and which will be available to public to provide feedback. Again, I just want to thank everyone for your participation, and we all look forward to more engagement with you in the future. Thank you very much.
Thank you so much, Michael. Ladies and gentlemen, this concludes today's workshop. Thank you so much for your participation, for your questions. We look forward to having you join us again later this month.